All right, let's get started. We're gonna discuss quiz 5 before we continue with for loop. All right, the first questions. So suppose you are given point grade which is initialized to some values, okay? And it asks you if you execute this code here, what would be the output, okay? So for example here, we have point grade is equals to 5. You initialize it equal to 5, and you say that if point grade is greater equals to 4, then your letter grade should be equals to A. Else, if it's greater equals to 3, letter grade should be equals to B. Else, it should be equal to C. And in the end, you print letter grade. So when point grade equals to 5, we will first test the first line. Line 1 is 5 greater equals to 4. Now this is true, and hence you do execute line 2, where letter grade now is equals to A. Now, once you have something that is true, you don't test line 3, you don't test line 5 anymore. You straight away out of the if statement and go to line 7, print the letter grade, which is equals to A. So the output is A. Okay. Second, when point grade is equals to 4, okay, so is this first line true or false? True? Yes. So point grade equals to 4, 4 is greater equals to 4, so letter grade is equals to A. So do you still execute line 3? No. So you straight away go outside if and go to print letter grade, which give you A. Now how about C here? If we have 3.5, point grade is equal to 3.5. If point grade is greater equals to 4, is it true or false? False. So if this is false, do we have letter grade equals to A? So what is it that we need to do next? We're going to check the next line. Is point grade greater equals to 3? Point grade 3.5 is greater equals to 3, so you have letter grade equals to B. And then that's it. Once you have something that is true, you don't continue testing anymore. You go and print letter grade. Okay, B. Now, how about point grade equals to 2? So again, you start from the beginning. Is it greater equals to 4? It's not. Then you check if it's greater equals to 3. If not, now else statement say that it has to be equals to C. So you print it and it's C. Now, how about equals to 0? The same thing. It is not equals to greater equals to 4. It's not greater equals to 3. It has to be C. Okay. And lastly, if it's minus 1, again, minus 1 is not greater equals to 4. You continue to test. Is it greater equals to 3? It's not. We're left with the else statement. It has to be equals to C. So I want to mention something. I'm going to create a new one. So Python is a dynamic data type where the type of the value depends on the type of a variable depends on the number that is the initialized value. Okay, so if I say point grade is equals to 5, okay, so the point grade value will change. The type of the point grade will change accordingly. It becomes int. But if I change it to now to 5.0, the type change accordingly. So what is the type of point grade at the beginning, it doesn't matter at all. Okay, it becomes matter when you ask user for input and you typecast it, that will become an issue. But when you initialize the value to some values, the type of point grade will depend on the type of the value. There will not be any error, even though the type of point grade had changed to int. For example, point grade equals to 5. If you run it, there is no invalid number, is still run accordingly because the type of point grade change according to the type of the value. However, if you were to write a code where you ask user for input, enter your point, okay, for example, and you were to do it with, for example, int. You typecast it to int, and then you run the following code. Okay, now if you give something like 5.0, you will get an error. All right, so then the type of point grade will become very important. Okay, it's because you want to ask the user to enter something, and then you're going to typecast it from string to int or string to float. All right. In that case, it becomes an issue when you put either 5.0 or 5. Okay. So in this case, if you want to allow the user to put floating point number, in particular, for example, 3.5, you have to typecast is to float. Okay. So that's the difference between the two. When you initialize it to something, the type of play grade will change according to the number that you initialize. So it won't have any error occur here. Okay. But in here, if you put int instead of float and user enters something that is a decimal, then the code becomes invalid. There will be an error. All right. So this is different from other programming languages, such as C, C++, where you have to define the type of the variable. So for example, in C++ or C# or anything, so you have to define the type of the variable, such as int point grade equals to something. So once you define it, you want to change it, then if you put int point grade equals to 5.0 or 3.5, then it becomes invalid. That is for other programming language. For Python, as we have mentioned, we don't define the type of the variable. It's defined based on the number that is initialized. Okay. Now let's go to questions 2. So you are asked to write a program to ask user for an input for an integer, which represents the amount to withdraw from an ATM machine. If user's input is valid as in it has to be an integer, this is an ATM machine that can only deal with integer, you display the updated balance to user. So the updated balance will be balance minus the amount that users input. All right, otherwise display invalid input, amount entered has to be an integer. Now, here I have balance equals to 100, amount withdraw is equals to input. Now notice here, I don't typecast immediately because I wasn't sure if the user are going to give me integer number or not. If it's not going to give me an integer number, if I do typecast int, just like what we have seen here, it will give me an error. If I do int here, it will immediately give me an error, and we don't want that, for example. Okay, so what we're going to do is that we don't typecast it, but we check whether it's a number or not, it's a digit or not. So here, if amount withdraw dot is digit, so if it is digit, then we know we can do the typecast int of amount withdraw and use this amount of withdraw after typecast to be deducted from the balance. So the new balance is balance minus int of amount withdraw. Okay, so that's the answer for these questions. Now some of you do one step further. So in these questions, I make it very simple. I did not, for example, I did not say that I did not make it clear, or I did not specify this, the user cannot enter negative numbers. So because usually in ATM, you don't have a negative button, so we don't expect user to be able to put negative number, but some of you put that int of amount withdraw must be greater or equal to 0, okay? And some of you even put it further, it cannot be less than $100. It cannot be exceeding $100. It cannot be exceeding the balance. So what you do is the int of amount withdraw is greater, is less than equals to 100. So this is all accepted as well, but it wasn't asked for in the questions, okay? However, some of you, when you do that, you forgot to typecast it. And I don't think we deduct any marks for this, but remember, amount withdraw is a string. When you compare it, whether it's greater equals to 0 or less than equals to 100, you have to compare it as a number, okay? So you have to remember to typecast it, all right? So the solution, so this is just, should be just here. All right, so I have to mention something here. So in quiz, because this is the first time you see these questions, we tend to be very lenient in grading. All right, if you put something that is wrong, we only minus 0.5 marks out of the total marks most of the time. Now, if the error is consistent. However, in the midterm, we will be less lenient in grading it. you shouldn't make the same mistake twice. Okay, so please go through your quiz, and if you have marks deducted, please go to the tutoring hours or come to me to understand why your points get deducted, so you don't make the same mistake again. And your midterm will be of the same format as quizzes as well. It comes with, some of the questions come with the sample code, so make sure you review all your quizzes and don't make the same mistake again. Okay, we will not be that lenient in grading midterm. And that's all for quiz. Any questions?
Balance and inference versus string.
Balance here. So what is this number? 100. So what is the type of balance?
Assuming it's an integer, but
it is an integer. Okay, just like we have here. If point grade equals to 5, the type of 5 is in, so point grade will be of type in. Does it make sense? Okay, good. So Python is very easy in the sense that you don't have to keep checking what is the type of this variable, what is the type of this variable. It depends on the number. So in other programming languages, once you declare the variable, you declare the type, it's difficult to change it afterwards. Okay. Now, if there's no questions, we go back to the for loop, which is what we're gonna do a quick recap. Okay, so for loops iterate on iterables. It performs what we call repetitions. So repeat something. All right, when you iterate over something and you repeat something. All right, so what are the iterables? We have seen that it includes list, string, set, and lastly, we have learned a new thing called range. Okay, so here's an example. It basically say that for x in 1, 3, 4, okay, so it's gonna iterate over this list contains number 1, 3, and 4. And for each one of them, you print x. So in the first iteration, x will take the value 1 and print 1. So this is what you get. In the second iteration, x will take the value 3, and then you print 3. That's the output here. And then in the third iteration, x will take the value 4, and then we'll print 4. And the end. So you iterate through every element in the list and then repeat this command here. Okay. Now the same thing with a string. It also works the same. It iterates through every character in this string here. 1, 3, 4. So x will first take 1 and then 3 and then 4. Now in the set, on the other hand, so what you type here is not what's being stored. What is being stored is stored as 1, 3, 4 because as a set, you only store the unique value. Okay, so the same, you have print 1, 3, 4. Now for range, is something that we have studied. So it generates integers from start to stop, but exclude the value of stop. All right, so you take two values, start and stop. You generate integers starting from start value all the way to stop -1. Okay, it does not include the stop value. Okay, it can be supplied, you can omit the value of start, then by default, it will start from 0. Okay, now, for example here, range 1, 5, it will generate integers from 1 to 5, but exclude 5. Now, if you run it, it will just give you range 1, 5, because it generates integers on the fly. So it's like after one integer, it will generate the second integer one after another. So it's more memory efficient compared to when you are in the list. All of these elements here will be stored in the memory. 1, 3, 4 are stored in the memory. So if you have a list of 100 elements, you have 100 memory for each of these number being occupied. But range, on the other hand, all right, once you generate integer, it's used, it's not going to use it again. It's going to discard it. It will generate the second value. So every time you only require one memory for each generations only. Okay, so it's become more efficient when you want to do this. But if you want to see, for example, what is being generated, you can also type cut this to list. Okay, say range 1, 5. If you want to see what is being generated, you can type cut this to list. For example, here it say that range 1, 5, you generate integers 1 all the way to 5 - 1, which is 1, 2, 3, 4. Okay, but remember, when you want to iterate over something, over integers generated from start to stop -1, you use range, you don't use list because we want it to be more memory efficient. So what do we use range for? Okay, so one thing, we use range, for example, to iterate over the list. the indices of the list. All right. So here, for example, instead of iterate over element in the list, we want to have more information about which element correspond to which indexes. So we iterate over the indices of the list. Okay. So for example, if you have a list, if you want to iterate over list L, okay, over indices of list L, okay, what you do is that you run the for loop for I in range L. So this is what's to the right. Can you tell me, is this right or wrong? So if you have a list and you want to iterate over the indices. Okay, suppose this is my list L. Okay. So I have L equals to this. All right. So for I in range of L, we want to print at index I, the value is something. Okay. So in dot format ILI. So you're gonna print the index and the corresponding value at its index. All right. So when you run this, there will be an error, and I want you to figure out what is the error. List object cannot be interpreted as an integer. Where do you think the error is? So we are looking at range of L. What is L here? It's a list. But when we do range, we always have integer. So we are not looking at range of L. We are looking at range of length of L. Okay, the number of elements in L. So this is the correct code. And I saw many students did that. So it's remember, you're doing range of length of L. That will iterate all the indices of the list. So starting from index 0 all the way to index 2. Okay. Now, another thing that we can do is to repeat code. All right, that we have seen, for example. So a very simple example. Say you are asked, suppose you work in an office where the supervisor say, can you create a program where it will emit a ticket in a counter ticket. So the ticket can only emit 100 tickets. Okay. So you are asked to program a ticket machine that gives out 100 tickets per day. Okay. So every time someone come in and press the ticket buttons, for example, in the bank, if you want to go to the cashier, you first have to press a ticket, get the ticket number, and then you wait for your ticket, your call for the ticket number. So suppose every time the bank can only serve 100 customers, so they will only admit 100 tickets. So you know that you're gonna repeat this statement of admitting a ticket 100 times. So for all I in range 100. So this will repeat something for 100 times because range 100 generate integers from 0 to 99. So there will be 100 elements. So range 100 generates integers from 0 to 99. So in total, 100 times. Okay, so iterate 100 times. All right, so for each of these, you're gonna emit a ticket, print ticket I is issued, for example. Ticket I is issued. Right? So every time somebody press it, you will say ticket 0 is issued, ticket 1 is issued, ticket 2 is issued. Okay, for example. So probably you want to say, you ask for user input first. You want it to be more real world scenario. So you will get input, enter your name, for example. Okay, and then you ask ticket is issued to user input. Okay. So then whenever user comes and he press his name or initial or something, and then it will say ticket 0 is issued to some name, and then you wait for a second customer to come. If the second customer come with a different name, then it will say ticket 1 is issued to something, etc., etc. So you have a record of which ticket go to which name. Okay, so you basically repeat this code 100 times and using the for loop. Okay, and you can stop at any time. Now let's do these are all just recap. Now let's use for loop for other things. Okay, that is, we want to sum some numbers, some integers, for example. So if I say quiz is equals to, say, 5314, just for example. Suppose I only have 4 students, and these are the score for a particular quiz for all my students. All right, and I want to know the average of the quiz. So the average will be the sum of the quiz divided by the length of the quiz. So when you want to do sum, so to perform sum of all numbers in quiz, so you can do sum quiz. This is using the built-in function. Okay, so this is using built-in function, and you have already learned it. Now suppose you don't have this sum function. This is what built-in for you. Suppose you want to create your own. How would you do it? Suppose you are asked to write your own sum function. How would you create it? Now this is very simple, because you just imagine you have this quiz score 5214. All right, and if you want to perform sum by yourself without using built-in method, what would you do? When you do it by hand, what you do is that you take the first number 5 plus 2, which is 7, whatever, which is sum of 5 plus 2, which is 7, and then you add the next number 1 to this sum. 7 plus 1 is 8. Okay, so you basically keep something in your hand. You have 8 now, and then you're going to add 4 to this 8, which is 12. So what we do is that we take some value that we know at the beginning is 0, and then you add the subsequent value. 0 plus 5 is 5. So I have something that I store as 5 temporarily. And then I take the next element 2, add it to this sum here, which is becomes 7 now. And then I take 1, add it, now becomes 8. I take the next one, 4, 8 plus 4 becomes 12. So what we did is that we repeat something. We take the next element and add it to the previous sum. So this is what we're going to execute by ourselves. So to execute sum without using built-in methods, built-in functions, what we do is that we iterate over the elements in the quiz. So this is the list that I want to add. Every element in here I want to add. So I iterate over the elements in quiz. Okay. And at each iteration, I'm going to take the element, add it to a variable core sum or core 10 if you want to. Okay. I just don't want to confuse. For example, I call it sum. Okay. Or result. I call it result. Okay. So we're going to repeat this until you at the end of the elements in the quiz. So at the beginning, if you say that you want to add it to a variable called result, you need to initialize what is result. So you're going to initialize a variable called result. At the beginning is 0. Okay, so it's 0. First result is equal to 0. And then you add the next element in quiz, which is 5. 0 plus 5 is 5. So now result takes the value of 5. And then you continue. You take the next element, becomes 2. 2 will add into result, so becomes 7 and so on. So this is what we're going to do. We're going to write for loop over all elements in the list. Before that, we're going to initialize result equals to 0. So the first step, initialize a variable called result equals to 0. All right. So at every single iteration, we're going to update the value of result. Okay. So for X in quiz, for every element in the quiz, we're going to add it to result. So result is equals to result plus X. And then at the end, print the total sum of score in quiz is, for example, result. Okay, so we say that the total sum of score is 12. So if you want to be more precise, so first in line 1, result is 0. Okay, now you execute line 2. Okay, you're gonna iterate x in quiz. Okay, look at our quiz here is 5214. All right, so when you start line 2, x takes the value of the first element of the quiz, which is 5. Okay, so recall that quiz is 5214. Okay, so when you execute line 2, x will take the value of the first element of the quiz, which is x equals to 5. And then you go to line 3. In line 3, you will have result is equals to result plus x, which is 0 plus 5. So result now takes the value. Result is 5. Okay. And then because you are in a for loop, when you reach line 3, you go back to line 2. Okay, now you go back to line 2. And this time, x take the next value, which is 2. So x is equals to 2. And then you go to line 3. And result is equals to, which is the previous value of the result, which is 5, plus 2, which is 7. And then you go back to line 2 again. Take the next value of x, which is 1. X equals to 1. And then you go to line 3. Result is equals to, take the previous value of the result, which is 7. 7 plus 1, which is 8. So now the value of the result is 8. And you go back again. X equals to 4. And in line 3, result is equals to 8 plus 4. Because x equals to 4. Now this gives you, which is 12. So now, if you go back to line 2, that's the end of the quiz. There is no next value. So you go to line 5. So the end of iteration. So you go to line 5 and you print result, which is 12, which is what you have here. The total sum of score is 12. Okay, so here I want to mention there's a shortcut to write this. Result equals to result plus 1. The shortcut is this. Result plus equals to x. Okay, so it still gives you the same answer. So basically, result plus equals to x is equivalent to result plus equals to result plus x, which means the value of result now is the current or the previous value of result that you have already in the memory plus the current value of x. Whatever computation it is stored and updated into the variable result. Okay, so this is a shortcut of how to write using just plus equal. All right, any questions? So this is just a for loop to add values. Okay, now if you want to print out intermediate result, all right, so what you can do, so at the beginning, most of the students will have trouble figuring out what is the intermediate value. So you can print out the intermediate value at each iteration. Okay, so print, for example, the current sum of score up until this point is, for example, result. Okay, so you can run, for example, here. So as you can see, at each iterations, you add one value at a time from the quiz. It's starting from 5, okay? And then you add the next elements to become 7. You add subsequent elements. Now the sum becomes 8. And you add the next elements. The sum becomes 12. And at the end, we are at the end of the iteration. The total sum is 12. Now this result here, the variable result, is called accumulator, because at every iterations, you accumulate values in the iterations. So when we use for loop to accumulate some things, we call the variable that we use to accumulate where you add something to these elements and get updated at every single iteration. We call this variable accumulated data. Okay. Now, so you are thinking, so why do we need to learn this, right? Because, you know, as you can see, we can just do it in one line, sum of quiz using built-in method, because this is the fundamental. Okay, we talk about how to add value at every single iterations. So we're going to add something into this. For example, you have learned how to use if statements. Okay, so for example, suppose I want to take find the average or find the sum of quiz score that is greater than 5. Okay, sorry, greater than 3. Sum of quiz score that is greater than 3. All right. Now, in this case, we can't simply just use list sum of quiz. Okay, built-in methods do sum of all elements in quiz, but we are only in those that are greater than 3. All right, so we basically want 5 plus 4, which is 9. We don't need 2 and 1. We are not interested in these two. We only need to take care of those that are greater than 3. All right, so we can't just use the built-in method. However, we have learned how to create our own function sum, but we only require it to add those that are greater than 3. So we can just modify this code here a little bit. Okay, instead of adding every element, we're going to have an if statement inside the for loop to only add those that are greater than 3. Okay, so we can modify the above code to only add score that is greater than 3. If it's not greater than 3, we don't add it into our result. All right, so this is something that you can't do using the built-in method sum, but something you can do by yourself by just modify the for loop of the accumulator, assimilate sum of elements into the code. So here's what we're going to do is that we don't add all x, okay? But we're going to have an if statement checking if x greater than 3. If x greater than 3, then we will add it into our result. Okay, so let's run here. The total sum of score in quiz that is greater than 3 is this. Okay, so it will be 9. 5 plus 4 is 9. Okay, so we don't add 2 and 1 in our quiz score here. We only add those that are greater than 3, 5 and 4. So as you can see, even though we have a built-in function called sum, you can just use easily to sum all the elements in the quiz, but you still need to know the fundamentals, how to create your own of a program to add elements in the list, because this is the fundamental block where if you want to modify or change the task a little bit, where you only add some of the values but not all the values, then you can't use the built-in function sum anymore, and you just modify your own code here, just add in an if statement to add those values that you are concerned with. Okay, so this is the code. So I want to ask you, if that's the case, if as an exercise, so suppose I want to say find the sum of quiz score that is, say, less than 3, less than or equals to 3. How do you modify the code to do that? Which part that you need to modify? So you can copy everything the same as before. So which part that you think you should modify? If you are just interested in those that are less than or equals to 3. The if statement. So what should we change here? Less than equals to 3. Okay. So for it's written as this, result is initialized to equal to 0 at the beginning is 0. For every element in quiz, if x is less than equals to 3, you add x into the result. Okay. And then in the end, you print the sum. That is less than or equals to 3. Okay. Now, let's take this further. Let's do counting. Here we basically take element, add it into result. Okay, so we focus on what is the sum of those scores that we are interested in. Now let's do, for example, here I have a quiz 1 score of students in 1200, for example, and I want to study how many students get score equals to 3. Okay, we have done this before. We can just use the built-in method .count. How many students get score equals to 3? 3 students get score equals to 3. You can just utilize the built-in method .count 3. So the method itself will count how many students or how many elements of 3 inside quiz 1. 1, 2, 3. 3 of them have, there are only 3 values of 3 in quiz 1. Okay. Now, what if, say how many students get score equals to 5? The same thing. Quiz 1 count 5. All right. Now, again, I'm checking if I want to say how many score less than or equals to 3. How many students get score less than or equals to 3? Now, you can only do quiz.count 3 to know how many elements of 3 inside quiz 1. Quiz 1.count 5, how many elements of 5 inside quiz 1. But how do we get score, how many students, or count how many number that is less than or equals to 3? Okay, so this is where you start to think, can I use the built-in method? So this only count exactly those that are equals to 3, exactly those that are equals to 5, but I want to know those that are less than or equals to 3. Not just 3, I'm also interested in those that get 0, those that get 1, those that get 2. Okay, so suppose I give you an assumption. Assumption is that all scores are integers. Okay, so all scores are integer. So in that case, okay, score that are less than or equal to 3 are 0, 1, 2, 3. Okay, because we say that all the score must be integers. So these are all the possible scores that are less than or equal to 3. It can be either 0, 1, 2, 3. So the number of students that get score less than or equal to 3 will be the sum of count of 0, 1, 2, and 3. So we can still utilize the built-in method. We say quiz1.count. So I count how many students get 0, how many students get 1, how many students get 2, plus how many students get 3. Okay, this will give me the number of students that get score less than or equals to 3. Okay, so this is how we can still use the built-in method. And again, if you have a score, say 10 or 100, and you want to say how many students they have score less than 50, and you don't want to repeat this plus quiz1.count all the way to 49, okay? So you can use for loop without to have to write down the summation of these many .count expressions, okay? So we can use for loop. Okay, so again, we assume all scores are integers. Okay, and now we use for loop. All right, just to avoid, because as you can see, this command, they are all the same. We just plus quiz1.count something. And what it will iterate over is 0, 1, 2, 3. So we have a repetition here. So we're going to do for loop for I in range. Okay, so we have 0, 1, 2. We basically require to generate integers 0, 1, 2, 3. Okay, we need to generate integers 0, 1, 2, 3. So what should be this value here? 4, good. Range 4 will generate integers 0, 1, 2, 3. Good job. So we have for I in range 4, we're going to do quiz1.count I. But we need to add it to something. What do we add it to? Say result. Add it into result. And before you do that, remember, you need to initialize it to 0 first. We start with 0, we continue to add it. All right. So here we have, and of course I need to print the result in the end, it still gives me the same number, 7. Okay, so here we have the advantage of running a for loop without having to explicitly write down quiz1.count this many times. Okay, so if you encounter something like this repetition, and with only changes in, for example, here from 0 to 3, then you know that you're going to run a for loop to range 4 because it will generate integer 0, 1, 2, 3. And we have quiz1.count, which will add, we got a plus, add into something, which is our temporary result. Okay, result is initialized to 0. Okay, now this is assuming that the scores are integers. Okay, now what if the scores are not integers? So to think, what if the score are not integers? I mean, can take non-integers value. The score of quiz can take non-integer values, such as 3.5, 4.5, etc. Okay, and then you say that, okay, so if I want to do this again, so now assume all scores are not just integers. So we don't have these assumptions. Okay, scores can take decimal values. Okay. All right, so scores now, they are less than or equals to 3, can be what? 0. It can be 0.5. It can also be 0.1. It doesn't have the 0.5. It can be 0.2 and so on. So can we enumerate this? Can we enumerate all possibilities? In fact, if you're talking about all the decimal values, it can be 0.0098 and so on. So we can't do that anymore. We can't enumerate this finite number of them. Okay. And suppose, so they are infinite numbers. Okay. So they are infinite numbers of scores that are less than or equals to 3. Okay, so we can't use for loop in this case anymore. So not that we can't use it. So we can't use dot count to enumerate all these numbers anymore. We can't enumerate all these numbers. Hence, we can't use dot count. Okay, remember dot count takes some value and then you count how many items in the quiz there is of this number here. But there are many possibilities from 0 to 3, including 3. If you take decimal points value, it can be 0.1, it can be 0.2, it can be 0.125, for example. So this code here only works if they are of integers. It doesn't work when we can allow non-integers values. Now, in the next slide, we're going to look at how to deal with this situation where the score can take decimal values. All right, so we're going to stop here for today. And if you have questions, please ask.